Hello. Good morning, Shish. Gopal Rao Shish. Yeah. Hello. Good morning, everyone. So, as discussed, just let me fix my mobile phone so that I can see the chat. Yeah. So as discussed, today we are going to discuss the chapters moving charges and magnetism, magnetism and matter, and electromagnetic induction, along with a few questions from electromagnetic waves. So we will complete that chapter into this session. So we will discuss 4 chapters all together, and if you are here, say hi. Okay. Hello class. Hello. Now, so as usual, without any delay, let us start with today's session. So I hope that you had your tea, had your breakfast. Okay, I will not take too long, obviously. I will try to close it by 11. So that is my plan. So 2 thin long parallel wires separated by a distance r from each other in vacuum carry a current I of I ampere in opposite directions, then they will. It is from KCET 2025. So here we have 2 parallel wires carrying current I. Both of them are carrying current I, but they are in the opposite direction. Now we know that current, in case of current, if the direction are same, okay, they attract each other. If they are opposite, they repel each other. So basically they will repel each other. Now the distance between them is given here r. Both of them are carrying current I. So what is the force per unit length? Force per unit length will be I1 I2, that is I square mu naught by 2 pi r. Mu naught by 2 pi r. Okay, so this is the formula for force per unit length. We have done this derivation for our PU exam. So that means correct answer will be repel each other with the force per unit length mu naught I square 2 pi r. Okay, I1 I2 both are same, so it will be I square. So repel each other with force per unit length r. Option elimination method. Okay, I'll see if the question is difficult where you are not able to answer it directly, then I will teach you. This is an easy question. Okay, so for easy question, option elimination method does not work. Okay, a solenoid is 1 meter long. For not all question you can do option elimination method. Okay, for some questions you can, okay, but not for all questions. For example, this is a calculation based question where and if you see that all the options are very close to each other, so you cannot actually do option elimination method. Okay, so you have to do some calculation. A solenoid is 1 meter long and 4 centimeter in diameter. It has 5 layers of windings of 1000 turns each and carries a current of 7 ampere. The magnetic field at the center of the solenoid. Again, easy question. So magnetic field at the center of the solenoid is given by mu naught into number of turns into I. Now here the trick is, here they have given 5 layers of windings. 5 layers of winding means, so this you have to understand. If there is a language jargon that you have to understand. So 1 layer means this is 1 layer. 2 layer means another layer on top of it. Okay, 3 layer means another layer on top of it. Okay, so 5 layer means basically each layer has 1000 turns. So 5 layer means total number of turns is 5 into 1000. Okay, so this is the total number of turns. Okay, now here number of turns per unit length is total number of turns divided by length of the wire. So length of the solenoid. So length of the solenoid given here is 1 meter long. So it will be 5000 by 1. That is 5000. So basically 5 layer means 5000. Okay, 1 layer means 1000, 5 layer means 5000. That is the main thing. Now current is given 7 ampere. Now we know that mu naught is 4 pi into 10 to the power of minus 7. So these are the variables that you have to remember. Number of turns is 5000 and current is 7 ampere. Okay, so let's see what is the value. 20, 20, 4 5s are 20, 20 into 7 is 20 into 7 is, okay, let me do one more thing. Let me write pi as 22 by 7, our old friend, okay, into 5 into 10 to the power of minus 4 into 7. So these three zeros I have adjusted with 10 to the power of minus 7. Okay, so 7 7 cancels and we get this as 20 into 22, that is 44. 44, 440 into 10 to the power of minus 4. Okay, now if you see the option, which option you think is correct match? So obviously this is not correct match. This is not correct match. This is the correct match. Okay, so if you take two zeros from here, that is 4.4 into 10 to the power of minus 2. You can write this as 4.4 into 10 to the power of minus 2. So correct match is this one. Okay, now why there is a difference in the question? It is 4.396, we got 4.4. obviously it is very close. But why there is a difference? Because obviously we have taken pi value as 22 by 7. It does not matter, as long as you have calculated it properly, you should get a very close match to the value. Okay, based on question to question, you have to adjust your answers such that you don't have to do a lot of mathematics. Okay, this is very, very important. Two similar galvanometers are covered into an converted into this not covered, it is converted, okay, into an ammeter and a milliammeter. The shunt resistance of ammeter as compared to the shunt resistance of milliammeter will be. So here we have an ammeter and a milliammeter. Okay, now smaller the amperage, that means smaller current it can measure. Okay, that means it must have a smaller shunt. Okay, smaller shunt. Why smaller shunt? Because it will allow most of the current to pass through this shunt resistance. Okay, or what? Let's see. So if you have doubt, let's see. So suppose a current of ampere range passes through the ampere, and only the current which is allowed through the galvanometer passes through the ammeter. That means remaining I minus Ig actually passes through the shunt resistance. Now let me take values, that will be easier. Suppose we have an ammeter, a galvanometer, basically a galvanometer which can maximum allow say or 1 milliammeter to pass through it, 1 milliammeter to pass through it. Okay, now suppose we have an ammeter which can measure in amperes. Okay, have a current say 1 ampere passing through it. Okay, that means how much current is being passing through this shunt resistance? 0.99 ampere is passing through this, and 0.1 ampere is passing through the ammeter. Okay, not even 0.1, it will be 0.001. that means here we have 0.001 ampere is passing through it, and 999 ampere is passing through the shunt resistance. Right, now what about milliampere? Milliammeter, obviously same galvanometer is converted into milliammeter. Okay, now suppose we have 10 milliampere which is passing in the circuit, only 1 milliampere is passing through the milliammeter, and remaining 9 milliampere is passing through the shunt. So shunt is basically handling a much less current here. So for less current we require higher resistance, for higher current we require very small resistance. Okay, smaller the resistance, it allows more current passing through it. That means 0.99 milliampere, that means ampere will have a shunt resistance much smaller compared to the milliammeter. Okay, so the shunt resistance of the ammeter will be much less, not only less, it will be much less compared to that of the milliammeter. You can calculate the potential drop, you can calculate that way also, but this is the way to understand that because ammeter handles much higher current, but the overall current through the ammeter remains same. Ammeter cannot handle more than this current. That means remaining current has to pass through the shunt. Okay, so the smaller the shunt resistance, higher current it can take. That means it has to be a smaller shunt to convert into an ammeter than to convert into an milliammeter. Okay, identify the correct statement. A straight current carrying conductor has circular magnetic field lines around it. The direction of magnetic field due to a current element is given by Fleming's left-hand rule. The magnetic field inside a solenoid is non-uniform, which is wrong. Okay, a current carrying conductor produces an electric field around it. Current carrying conductor does not produce any electric field. Now what is correct? A small shunt cannot pass more and zero is not possible as should pass something. Yes. Okay. A small shunt cannot pass more. I don't get your point, class. Yes, shunt resistance is low for ammeter. Yes. Okay, now between these two, option A and option B, we have to eliminate the wrong answer. Okay, direction of magnetic field due to a current element is given by Fleming's left-hand rule. Fleming's left-hand rule gives what? Fleming's left-hand rule gives you the force acting between two magnetic field and a current carrying wire. Okay, force acting between magnetic field and current carrying wire is given by Fleming left-hand rule. Fleming right-hand rule gives the induced current direction. Okay, the direction of induced current is given by Fleming's right-hand rule. Left-hand rule gives you the you have a current carrying wire, there is a magnetic field around it, what direction force will act on it. So Fleming's left-hand rule is called motor rule, and right-hand rule is called generator rule. Okay, so definitely this is not correct. And a straight current carrying wire has a circular magnetic field lines around it. So if this is a current carrying wire straight, you have done this experiment in your class 10th, not physically but through your books. Okay, current carrying wire, you have some iron filing spread over the cardboard. You tap the cardboard, you observe some circular patterns emerge inside the cardboard. So that means it is a circular current carrying loop. So this is the magnetic field lines. Okay, if you remember in your class 10th, magnetic effect of electric current, there you have studied it, right? So it will be correct answer is option A. Don't worry if someone answers wrong, it is fine. Okay, don't blame on each other. There are students, they will answer wrong, there are times you will answer correctly. So don't worry if your answer is wrong. You understand the concept, that's why you are here. So if you are not here and then in the exam you answer wrong, that will harm your prospect. But if you answer here wrong, understand why you are answering wrong and you don't repeat the mistake in the exam, that will be better, right? Which of the following graphs represents the variation of magnetic field B with perpendicular distance small r from an infinitely long straight conductor carrying current? Okay, very easy question. Which of the following graphs represents the variation of magnetic field B? So magnetic field B due to a very straight wire carrying current. Okay, with a perpendicular distance r from an infinitely long current carrying wire. So it is given by mu naught by I by 2 pi r. Okay, so this is the formula for a current carrying wire. You can use Ampere's circuital law to find this, very easy derivation. Okay, so what is the graph? So magnetic field is inversely proportional to the distance. That means obviously inverse proportional graph, option A is correct. Okay, inverse proportional graph. Now remember, if you want to guess, suppose you don't know an answer, the graph based question is given. Okay, there is a chance, I always mention that 90% chance is that this pattern will be correct. Okay, there are 10% cases where different pattern is given, but in KCET loves this pattern. Okay, maybe they will hurt me through this lecture and they will change the pattern, that is a different issue. But in 90% cases, if you don't know the answer, if you want to guess, that will be the chance of correct answer. Okay, KCET love this pattern. Now let's move on to the next question. Before moving on to the next question, just few hours left before you the registration for KC30 batch closes. Okay, you have already more than 500 students registered only for KC30. So including KC30 and KC90, we have more than 1000 students registered. So if you still want to score well, if you want your personal doubts to be resolved through experts, obviously I will be the expert for physics, for maths Ankit sir will be the expert, for chemistry Ekta ma'am will be the expert. So if you really want to resolve your doubts, you want to study in a structured way, okay, already P1 lectures are over, P2 just starting now. So if you still want to join the batch, you can join today. Okay, the link of KC30 batch is given in the description section of this. Obviously price is 2499. Okay, so don't wait till it's too late. If you still think that my preparation is not going as per plan, I want a proper guidance, proper structured way of preparation, then definitely you should join KC30 batch today. I think the registration will be closed very, very soon. So don't wait till it is closes. Okay, the batch will be closed very, very soon. ABHYAS KCET also is there, but ABHYAS you can purchase anytime. ABHYAS is still open. ABHYAS will remain open, but KC30 batch will be closed. So if you still want, you can join. Now, a moving electron produces only electric field, both electric and magnetic field, only magnetic field, neither electric nor magnetic field. Okay, so electron, moving electron. So moving electron is basically obviously a charged particle. A charged particle will have an electric field on its own. Now when it is moving, what will happen? It's fine, Shravya. Okay, I don't have any problem, obviously. Okay, if you can make wrong answer, don't worry, don't think about. See, you have to be clear to yourself when you are answering. Are you answering honestly? If you are answering honestly, if it is wrong, that does not matter, because you may have misunderstood the concept. Now try to learn it and improve from there. That is very, very important. Okay, now Aryan and Shravya, please calm down. Hi Jia. Now, what is the answer to this question? So electric field is always there. Electron is there, static or moving does not matter. It will always have electric field. Okay, so and because of the motion of the current, motion of the charge, okay, it will produce a kind of current. So that means it will also produce magnetic field. Okay, both electric and magnetic field. Okay, a moving electron produces both electric and magnetic field. Now here a very important concept to remember, that when the electron is flowing inside a conductor to produce a current, okay, when an electron is moving, suppose an electron is moving inside a conductor to produce a current, that electron is not a free electron. That electron is bound within the metal, so that electron will not produce any electric field. Okay, so the electric field produced by the moving electron inside a conductor, which is actually producing a current, will be nullified by, because the overall wire will be neutral because of the conservation of charges. So whatever electron is there, there will be equal amount of proton, so that will not produce any electric field. Okay, So current carrying wire that thus does not produce any electric field. Okay, current carrying wire, even though you can say that current carrying wire is a electrons are moving, but electrons are moving because of external electric field that you have applied. Okay, current electricity chapter we have learned that when you apply a external electric field, the electron starts drifting in one direction. Okay, this is very, very important concept. Okay, many students confuse and they make mistake. I hope if you are listening to this lecture and if some question comes based on this concept, you don't make that mistake. That current carrying wire, even though it's a motion of electrons, even though they are moving very slowly, drift speed is very slow. But still, that moving electron will only produce magnetic field. It will not produce any electric field. Okay, the main reason being that the overall conductor remains neutral due to the conservation of charge. Okay, charges are not being created over here. Charges are only shown at particular direction. Okay, charges are being shown a particular direction that you have to move from higher potential to lower potential. In case of electrons, it is lower potential to higher potential. Current will pass from higher potential to lower potential. Electron moves from lower potential to higher potential. So basically what happens is that you are showing a direction to the electron, but otherwise the conductor remains neutral, and because of that it does not produce any electric field. But as free electron, on the other hand, it has an electric field on its own. So a free electron will produce electric and magnetic field together, and not only that, if it accelerates, if the electron accelerates, it will produce electromagnetic wave as well. Okay, accelerating charge particle produces electromagnetic wave as well. Okay, now let's move on to the next question. A coil having 9 turns carrying a current produces magnetic field B1 at the center. Now the coil is rewounded into 3 turns carrying same current. Then the magnetic field at the center of the center B2 is. Now here, if you want to guess, you have to understand that a coil having 9 turns carrying a current. So 9 turns means it has a 9 turns. So initially it was 9 turns. Now you open the entire wire and now you have made only 3 turns. So definitely what happens, the coil becomes bigger. Coil becomes bigger means the magnetic field becomes less. Okay, bigger the radius, obviously inversely proportional to radius. So bigger the radius, the magnetic field becomes less. Now if you want to guess, okay, you should guess this answer. Okay, you should guess this answer. Magnetic field is getting 1/3. Now I might be wrong. Okay, either B by 9 or B by 3 should be the answer, because it's a ratio of 9 and 3. So I am guessing that it should be the B by 3 answer. Now we will check it. Okay, suppose initial radius of the wire was small r. After you rewounded the entire wire into 3 turns, now the number of turns is 3. Suppose the radius is capital R. Now what thing remains same? Okay, so class was asking, sir, how to guess, how to eliminate the options. So elimination method is, obviously bigger ones will be wrong. Okay, smaller one will be correct. So out of these two you have to choose. I am choosing this, as I mentioned. Okay, because obviously the 9 B by 9 may not be the correct answer. So let's see. So initially total number of turns was 9. So what will remain same? The length of the wire will remain same. So what is the length of one single turn? Length of one single turn is 2 pi r, right? What is the length of 9 number of turns? Length of 9 number of turns is 2 pi small r into 9. Okay, length of the entire wire is 2 pi r into 9. Now here, what is the length of one turn? Length of one turn is 2 pi capital R. And what is the length of total wire? Length of total wire will be 2 pi capital R into 3. Right? So 2 pi cancels, and we get that capital R equals to 9 into R by 3, that is 3R. So 3R is the radius. Now what is the magnetic field at the center of a coil? Magnetic field at the center of a coil is given by B1 equals to mu naught by 2 I by R. Okay, mu naught by 2, there is no pi over here, mu naught by 2 I by R. So that is the magnetic field at the center of a coil, right? So so initially this is the magnetic field and current remains same. Sorry, one more thing you have to take, that is the number of turns as well. You have to take number of turns as well. So mu naught by 2 I Ni by R, so it will be mu naught by 2 9I by small r. Okay, initially the radius was small r, so let me correct that. Okay, mu naught Ni by small r. Now what is the new magnetic field? New magnetic field B2 is again the same formula, constant will remain same, even if you make the mistake in the constant does not matter. Okay, now it will be number of turns divide into I divided by the new radius. Okay, now what is the now magnetic field? It will be mu naught by 2, number of turns is 3I divided by what is the radius? Radius is also 3r. Okay, so it will be mu naught by 2 I by R. So I was wrong, so correct magnetic field will be B1 by 9. Okay, so it will be B1 by 9. So you have to be careful. Even I have guessed that B1 by 3 could be the correct answer, but after solving it I realized it is not B1 by 3 but it will be B1 by 9. So even if you eliminate two options, it is still tricky to guess the correct answer. Okay, if there is a possibility that you know the theory, you solve it. If you don't know the theory, okay, you have to guess one of the two options. 50-50 chances is very much possible. In most of the cases, unless the values are very close to each other, only 10 to the power values are different. Okay, otherwise if it is a question like this kind of questions, 50-50 chance can be, you can get a 50-50 chance. You can eliminate the options which are wrong, but here after elimination that becomes tricky. Which one will be the correct answer? Either it will be B1 by 9 or it will be B1 by 3. Okay, I intentionally chose the wrong answer so that you might think that okay, it will be B0 by 3, but don't have a prejudice in your mind. So if you are not sure, you can guess one of the two options. If you have time, if you get some time, if you know how to solve it, solve it. Okay. Now next question, a particle of specific charge Q by M. Specific charge means the ratio of charge is to mass is called specific charge, is given by pi coulomb per kg, is projected from the origin towards positive x-axis. Indrama, I am taking classes because Ankit sir is not well. Okay, this class was supposed to be taken by Ankit sir. So Ankit sir is not well. Once he recovers, he will take the class of mathematics. And don't worry, as long as you practice, keep on practicing, that is good for you, right? Our physics syllabus is going faster than mathematics. In live classes we take PYQs, and we after 15 days, don't worry, we will solve questions as well. But first 15 days, that is the 15-day challenge, that is this series going on. Here we are trying to cover all the important PYQs, and then we will be solving new questions. Okay, don't worry if you are thinking that only PYQs is being done. PYQs are 50% of your preparation. Okay, so if you have solved the PYQs, 50% of your preparations are done. Remaining 50% is practicing questions. We will solve questions in upcoming week. Okay, so don't worry, out of the 15 days challenge, I think 1 week is almost done. We have covered our PU2 chapters, PU1 chapters, PU2 chapters is currently ongoing, and soon we will start with the new questions in upcoming week. Okay, and once Ankit sir recovers, he will take the maths class. That's why I am taking back-to-back classes. So those who are wondering why I am taking back-to-back classes yesterday evening, today morning, because of this issue. Okay, so once Ankit sir recovers, a doctor asked him to take 3 days rest. So today is the second day. After tomorrow, I think day after tomorrow, Ankit sir will start taking classes. Okay, so don't worry. A particle of specific charge Q by M equals to pi coulomb per kg is projected from origin towards positive x-axis with the velocity 10 meter per second in a uniform magnetic field B equals to minus 2k_t. The velocity v of the particle after a time t equals to 1/12 second. Very interesting question. Okay. So if you see that the magnetic field is along the negative z-axis and particle is projected along the positive x-axis. That means the angle between magnetic field and velocity are 90 degree. Okay, so it is the magnetic field is along negative z-axis. Suppose this is the z-axis and suppose this is the x-axis. You can choose x, y, z based on your requirement, right? So x cross y equals to z. X cross y equals to this, so y axis is somewhere here. So this is y into the page of the paper. So this is the positive z axis, this is negative z axis. So if you see that, what will happen, because the angle between the velocity and magnetic field is 90 degree, what will happen, it will start rotating in a circular motion. Okay, the particle will start rotating in a circular motion. And because of the circular motion, what will happen is that we have to find, the first step is to find the time period of the motion. Okay, once we calculate the time period, then we will be able to solve this question. So how to find the time period? Time period of, if I remember, time period of motion, let me do a small derivation. M omega square r equals to m into r omega mb by qvb. Okay, so this is the required centripetal force for the motion, and this is the Lorentz force. Both has to be same. And V is Q into R omega into B. So we get omega equals to QB upon MR. QB by M is the angular frequency. So time period will be 2 pi by omega. So that is 2 pi M by QB. So this is the time period formula. 2 pi M by QB. So now we know 2 pi M by QB. Now we have to find the time period, so that we will see that how much angle it will rotate after t equals to 1/12 second. Okay. So let's see. So here Q by M is given as pi. Q by M is given as pi. So M by Q. So M by Q must be equals to 1 by pi. Okay, so basically this, to cancel this extra pi, the pi is, this value is given such a way. Okay, so 2 pi into 1 by pi. Okay, this M by Q becomes 1 by pi. So that's how, this is the relative charge, and magnetic field is given as -2. So magnitude wise it will be +2. So pi cancels, 2 cancels, we get time period equals to 1 second. Okay, so now if we know the time period, what is the significance of time period? Time period gives you a time required to do a complete rotation, one complete rotation. Okay, so one complete rotation means you get pi by 2, pi, 3 pi by 2, 2 pi. Okay, so total angle in one rotation is 2 pi. So how much angle it will rotate if t is equal to 1/12 second? So the angle it will rotate will be 2 pi into time period, into time divided by time period. Okay, this is the formula that you need to remember. This is the angle rotated in, it is applicable for circular motion as well. So here you can calculate the theta to be pi by 6. Okay, if you put the value of t is equal to 1/12, you will get angle to be pi by 6, which is 30 degrees. Okay, which is 30 degrees. Now how to calculate this value? Okay, remember that one very important thing. Okay, when a particle is rotating like this, okay, in a circular motion, the velocity is in this direction. The velocity, magnitude wise, the magnitude of the velocity remains same. The magnitude of velocity remains same, only thing that changes is the angle, okay, angle changes. So you have to find the component of velocity along x and along y direction, okay. Magnitude wise it remains same. So it will be, so the velocity vector will be 10 into I cap cos theta, okay, if you take the component along x direction, because it was moving initially along x direction, so it will be cos theta plus j cap into sin theta, okay. So if you add these two, what you will get, if you take the square of these two and add it, you will get 1. So magnitude wise no problem, magnitude will still remain 10. Now how did I get the value 10? Because in the question it is mentioned that the velocity of the particle is 10 meter per second. It is not required to calculate the time period, but it is required to calculate this formula, okay. So when there is a vector like this, okay, so this is the x direction, this is y direction, so this angle is theta, so this will be cos theta component and this will be sin theta component, right. Now what is this vector represented by? This vector is represented by magnitude of this. So suppose this is a, so it will be a cos theta I cap plus a sin theta j cap. Obviously you can take a common and it is left with I cap cos theta plus j cap sin theta. So we calculated the angle to be 30 degrees, that is cos 30 plus sin 30. What is cos 30? Cos 30 is root 3 by 2 and sin 30 is half. So it will be 10 I cap root 3 by 2 plus j cap into half, okay. So it will be 5 into root 3 I cap plus j cap, okay. So if you go back here, it will be root 3 I cap plus j cap. So option C is correct answer for this question, okay. Hello, so C option is correct. Now if the same question was asked with the angle was initially given along y-axis, remember the axis with which it is given, that will give you cos theta component, and the other axis, the other remaining, so z-axis is magnetic field, that means the particle must move along xy plane. If the magnetic field is along y-axis, the particle will move in the xz plane, okay. So it will always be the other two components other than the magnetic field. So magnetic field was given in k cap direction, so that means the velocity will be have I and j cap, okay. If velocity is given in j cap direction, then magnetic field is given in j cap direction, then magnetic velocity will be I and k cap direction. So remember this, okay. And whatever direction initially given, that will have a cos theta component. That is how you should think and solve, okay. Now let's see this question. The magnetic field at the center of a circular coil of radius capital R carrying current I is 64 times the magnetic field at a distance x on its axis from the center of the coil. Then the value of x is. So basically here we have a magnetic field at the center and at some distance x. Okay, so what is the, this is said that the magnetic field at the center suppose is here suppose the magnetic field is B, then here it will be 64 times B. Then they ask you what is the value of this x, okay. How to solve it? Varu, I am talking the loudest way possible, and I can guarantee that I am the one of the loudest teacher in entire channel, okay. So if you are not able to hear me, there is no problem from my side. My device I checked, it is working fine, okay. So if you are not able to hear me, check your device volume. Some devices may not work, use headphone or earphones, okay. That will give you some better audibility, okay. I hope that helps. Now So how to solve it? So magnetic field at the center of the current carrying coil is given as B is equal to mu naught by 2 I upon R. Okay, I upon R. This is the magnetic field at the center. What about the magnetic field at some distance x? So this is Bx. Magnetic field at a distance x is given by mu naught by 2 I R square divided by R square plus x square to the power 3 by 2. This derivation we have done in our PUC exam, right? So it is mentioned that B equals to 64 of the Bx. Now you have to find this x distance in terms of R. Now let's put the values. Obviously mu naught by 2 will cancel. So I by R, mu naught by 2, 64 I R square by R square plus x square to the power 3 by 2. So mu naught by 2 cancel, I cancels, and if you do the cross multiplication, you will get R square plus x square to the power 3 by 2. Here we have 1. Now one of my student once, what she did, x by a equals to x by b. So they cancel and they said, sir, this is 0. Okay, so do not make it 0. This is actually not 0, this is 1. Okay, so anyway, that happens in the lower classes, but now you have to understand that this is not 0. If you cancel everything, that means it is 1. Okay, unless it is subtraction. So now here we have 1. So you cross multiply 1 into R square plus x square to the power 3 by 2 equals to 64 R square into R, that is R cube. That will be 4R whole cube. Now if you take cube root on both sides, you get R square plus x square to the power half equals to 4R, right? This cube and this cube are gone. Now square both sides, you get R square plus x square equals to 16R square, or x square equals to 16 minus 1, that is 15R square, that is x equals to square root of 15R. So it is square root of 15R. So correct answer is option D, not this one but this one. Okay, if you solve properly, you will get the answer. Tasmia itself is asking, Tasmia, where are you from? Right? Very interesting. The torque acting on a magnetic dipole placed in uniform magnetic field is 0 when the angle between the dipole axis and magnetic field is. So basically dipole related question can be asked from your magnetic field chapter, can be asked from your electric field chapter. Formula wise everything remains same. Okay, in case of electric field it is E into P into E cos theta. In case of magnetic field it will be a magnetic moment into B into, not cos theta, sorry. Torque is always sin theta. Magnetic field, magnetic energy stored or potential energy of the system is always cos theta, and that is minus. Okay, so for electric field, for the context, it is PE sin theta, and energy stored or potential energy of the system is minus PE cos theta, and this formula remains same for magnetic field as well. As long as you remember that it does not matter, only you need to change the dipole moment and electric field with magnetic moment and magnetic field. Okay, so here it is mentioned that the torque acting on it is 0. Torque acting on it is 0. So that means sin theta must be 0. So sin theta 0 means at what angle sin theta can be 0? Sin theta can be 0 only at 0 degrees. Okay, so that answer your questions, which is 0 degree. 180 degree is also possible, but 180 degree is not given in the option. So that means sin theta will be 0 at theta equals to 0 degrees. Okay, now let's move on. Which of the following statements is true in respect of diamagnetic substances? So what is the following is true? So this is a question from KCET 2025. Permeability is greater than 1000. We are talking about diamagnetic. Permeability is greater than 1000 is for ferromagnetic substance. Susceptibility decrease with temperature. Susceptibility is small and negative. They are feebly attracted by magnets. Susceptibility for a diamagnet is almost constant. It does not change with temperature. Okay, susceptibility for a diamagnet is actually very small and actually it is negative. Okay, susceptibility is less than 0. So a susceptibility for and mu, that is permeability is 1 plus susceptibility. So susceptibility is greater than 0 but very small value. Okay, susceptibility is less than 0 and permeability is greater than 0, but both of them are very, very small. Okay, so they are feebly attracted by magnets. This is not correct because they are feebly repelled by magnets. So correct answer is option C over here. Okay, next question. Universal property among all substances. Which of the property is universal among all substances? All substances have this property. Now let's see who can answer this. Yes. Good morning, Mir Jafar. Option A, yes, diamagnetism is the universal property. All substances, including paramagnets, ferromagnets, they all have inherently diamagnetism. I'm going to explain with one example. You will remember it forever. So we all what is diamagnetism? Diamagnetism is like we don't want magnetic field. We are repelling magnetic field, right? For example, we don't want to study. Okay, we want a relaxed life, we want to sit back, enjoy, right? We don't want to study in our life. Now some of you may be a good student, very good student, some of you may be average student, some of you are actually not willing to study at all. But out of all the students, if you give them an option, okay, they will say I will choose that, I will relax and I will enjoy, right? So diamagnetism is that property which gives you the idea of I don't want to study, I want to enjoy. But paramagnetism is like average student, ferromagnetism is the very good student, I attract everything on in my domain. So that's what ferromagnetism is. Paramagnetism is like average student. Okay, I may become a ferromagnet in future, okay, if I study properly, but I am very close to diamagnetism. Diamagnetism are those days, I will study, I will just pass the exam, that's it. Okay, so inherently everyone is diamagnet, but based on their conditions, based on their temperatures, etc., they behave like paramagnet and ferromagnet as well. Okay, now next question. Which of the following statement proves that Earth has a magnetic field? Earth is surrounded by ionosphere. The intensity of cosmic rays stream of charged particle is more at the poles than at the equator. The large quantity of iron ore is found in the Earth. Earth is a planet rotating about the north-south axis. Which property shows that, which observation shows that Earth is a magnet? Now remember that from this chapter Magnetism and Matter, there used to be some concept called hysteresis, then susceptibility, then Curie temperature. They are not part of the syllabus, they are deleted. That's why we are discussing some of the important questions which actually may not be PYQ, or I think this question came a little older, these questions are slightly older, but anyway, we have to discuss some questions. That's why we are discussing these questions, which are important in my opinion and confusing for you as well. So that's why, and if you see any Curie temperature based question where they ask you that how to calculate what will be the Curie temperature of this substance, those questions are now deleted. Okay. Third, which one is correct? So you remember that the Earth having ionosphere is nothing to do with the magnetic field of Earth. Okay, ionosphere is basically a region where ions are there, and that happens because of the ozone layer. Ozone layer breaks down ions, and the high energy particles which comes from the sun, okay, that breaks the atoms present in that layer into ions, okay, and it is nothing unique to Earth as well. So this is not a property for having magnetic field. Now, intensity of cosmic ray. What is cosmic ray? Cosmic ray is basically very high energy charged particle. Okay, they are moving very fast and they are charged particles. Okay, and when they enter the Earth, what happens is that because they have moving charged particle have their magnetic field, so they react with the magnetic field of Earth. Okay, so they either get attracted or they get repelled. Okay, so if they are moving such a way that they gets attracted to the North Pole, okay, they go towards North Pole. If they are repelled by North Pole, they go towards South Pole because they are getting attracted by South Pole. Okay, that's why we see the aurora borealis and aurora, one more aurora is there. So two auroras are there, and both auroras are seen from the Arctic region. Arctic region means the North Pole and South Pole region of Earth. So that is the reason that we see cosmic ray stream and charged particle is more on the poles than the equator. Equator is neutral zone, so that's why we do not see any auroras from our place. To observe aurora, you have to go to a country like Finland. Okay, Finland, Iceland, there you might see aurora because they are located very close to Earth's magnetic pole. Okay, now let's move on to the next question. In a permanent magnet at room temperature, domains are partially aligned, domains all are perfectly aligned, magnetic moment of each molecule is 0. The individual molecules may have non-zero magnetic moment, which all are perfectly aligned. So this is a permanent magnet. Permanent magnet means ferromagnet, obviously ferromagnetic substance. Ferromagnetic substance, they do form they do form domains, right? Now what about the domains? Are they perfectly aligned or not? That is the main question. So yes, for domains are not perfectly aligned. At room temperature means the atoms present inside the material, they are vibrating, they are not perfectly aligned. Okay, if they are perfectly aligned means you can create a very high value magnet. Okay, there are some specific materials, for example neodymium, some rare earth material, they actually get very close to perfectly alignment, they get 99% alignment. Okay, so you may have heard that China controls 90% of the world's rare earth magnets. Okay, they have the technology to mass produce rare earth magnets. India, unfortunately, even though they produce rare earth materials, they cannot manufacture the magnets, okay, because we do not have the technology. So those are certain materials which actually can be made to produce 99% aligned magnets, but even in that case they are not 100% alignment. Okay, so obviously 100% alignment means it will be a very strong magnet. Okay, so that's why domains are not perfectly aligned. It depends on the temperature. Okay, if you cool it down at some temperature, yes, they will perfectly align, but at room temperature, because it is mentioned at room temperature, domains will not be perfectly aligned, domains are partially aligned. Okay, based on the quality of the substance and the element used inside it. Okay, the percentage changes, but they are obviously not perfectly aligned. Correct is partially aligned, because temperature is not certain temperature. Okay, it will at room temperature, they will be, the atoms will vibrate because of the heat energy, and domains will partially align. Now next question. Needles N1, N2 and N3 are made of a ferromagnetic, a paramagnetic and a diamagnetic substance respectively. The magnet, when brought close to them, will attract all three of them, attract N1 strongly, N2 weakly and repel N3 weakly, attract N1 strongly but repel N2 and N3 weakly, attract N1 and N2 strongly but repel N3. So obviously here you don't even have to read the question deeply, you will be able to answer it if you understand the concept that one of them is paramagnet, one of them is ferromagnet, one of them is diamagnet. So obviously it will attract the ferromagnet strongly. Okay, it will attract the ferromagnet strongly. Secondly, the paramagnet will be attracted weakly. Okay, so weakly means not every week, weakly means very poorly. Okay, so it will be attracted N2 very weakly and it will repel N3 weakly because this is a diamagnet. Okay, now in case they change the order, in that case you have to figure out which one is diamagnet, which one is paramagnet, which one is ferromagnet. But from these kind of options are given, then you are sure that only one of them will be correct answer. If they mix the options, suppose they mention attract N2 strongly, N1 weakly, N3 weakly, then or N3 repel N3 weakly, so in that case you have to analyze. Such options are given means you don't need to analyze at all, because obviously you know one of them will be strong, one of them will be weak, and a third one will be repelled weak. Okay, so obviously option B is correct. Okay, this is how you should eliminate the other options as well. Now next, the magnetic intensity to completely demagnetize a ferromagnet is 3 into 10 to the power of 3 ampere per meter. The minimum current required to be passed in a solenoid having 1000 turns per meter so that the magnet gets completely demagnetized when placed inside the solenoid. Okay, so the magnetic intensity is given ampere per meter. Now you are asked that you are given a solenoid, okay, and you are given some number of turns inside it. Okay, now they ask you at what current level you can demagnetize the magnet if you place the magnet inside the solenoid and you pass a current opposite direction, okay, to reduce its magnetization. So how much current you require. Okay, so magnetic intensity is given, which is H. H is equals to B by mu naught. Okay, assuming, or B by mu more accurately. Anyway, so here we know that the magnetic field developed inside a magnet is given by mu naught Ni. Okay, so magnetic intensity will be B by mu naught, that is N into I. Okay, so you require this much magnetic intensity, and here number of turns is given. You just need to find the current. Okay, so H is 3 into 10 to the power of 3 and equals to N into I. N is 1000, that is 10 to the power of 3. We are trying to find I, so I will be equals to 3 ampere. I will be equals to 3 ampere. Very easy question. If you know what is magnetic intensity, what is magnetic field inside a solenoid. Now this is the mixed concept of this chapter and the previous chapter combined, but interesting question, not difficult, solvable quickly, easily, just you need to remember this formula. Okay, now this question, when a bar magnet is pushed towards the coil along its axis as shown in the figure, okay, the galvanometer pointer deflects towards X when the magnet is pulled away from the galvanometer pointer. Okay, so first of all, you have a magnet here, you have a coil over here, basically coil magnet experiment. Here you are pushing the magnet towards the coil. What happens? The galvanometer needle deflects towards X. Now when you move it away from the coil, what will happen? So basically we know that from the coil magnet experiment, when you push the magnet towards, if it is deflecting in one direction, when you pull it away, okay, then it deflects in the other direction. Okay, so it will deflect in the direction towards X1. Okay, X1 is here, X is here. So when you pull the magnet away, the galvanometer needle will deflect towards X1. Okay. 15 question is done. Guys, stop sending these weird emojis in the chat when I am discussing, I am teaching in that class. Okay, if you keep on sending those emojis, that distracts me. Okay, so don't try to distract me. If you have any doubts, any questions, do mention that. If you want to answer the question, mention the answer of that question, but do not send these weird emojis, right? Okay. Hello Shish. Okay, Prajwal, I saw you yesterday also, you are doing the same thing, right? After the lecture is over, I will be here for 2-3 minutes, then you send whatever emojis you want, right? Square loop of side 2 meter lies in the XZ plane in a region having magnetic field B equals to 5I cap plus 3J cap minus 4K cap Tesla. The magnitude of the magnetic flux through the square loop is. So here we have a square loop, okay, in the YZ plane. So YZ plane means what? If the plane is YZ, so suppose this is Y axis, this is Z axis, suppose, okay, the normal to YZ is always X. X, Y, Z are always perpendicular to each other. 3 of them. Okay, you can consider a corner of a room. So this is X axis, this is Y axis, then the top one is Z axis. This is like the way you remember. Okay, X cross Y equals to Z. So if this is X, this is Y, then the up one will be Z. So X cross Y equals to Z. Okay, now so that means if this is Y, this is Z, the other axis is always X cap or I cap. Okay, so the normal to the surface is always I cap. Now what is the area? Area of a square loop of side 2 meter is basically 2 into 2, that is 4 meter square. And what is the area vector? Area vector will be 4I cap, okay, meter square. Why we are finding area vector? Because magnetic field is given in vector form, okay, and we don't know that magnetic flux is actually B dot A. Magnetic flux is B dot A. So B is given, A we know is along I cap. So we don't need to write the entire thing. We know that when we are doing dot product, only similar vectors multiply, all other vectors become 0. So I dot I is 1, I dot J is 0, I dot K is also 0. So basically B dot A will give you this 4 into this 5. Both of them have I cap. That's why only 4 and 5 will be multiplied. Remaining quantities will not come into the picture. So don't try to find the magnitude and calculate. It will be simply 20 Weber. 20 Weber will be the answer. Okay, so correct answer is option D. So this is an easy question if you know how to solve it. If you don't know how to solve it, it might take a long time. Only thing, remember, the plane is given. Plane given means normal to the plane is the direction of the area vector. Normal to the plane is the direction of area vector. Area vector is always perpendicular to the plane. So XZ plane means the normal is along X cap, okay, along X cap. Now it can be positive, it can be negative. I am not saying that it is always in the positive direction. That is not, that clarity is not given in the question. But anyway, it will be along the X vector only. So it will, magnitude wise, it will be 20 Weber. It can be plus 20, it can be minus 20 based on the direction of the area, okay, and the magnetic field. But okay, a uniform magnetic field of strength B equals to 2 millitesla exists vertically downwards. These magnetic field lines pass through a closed surface as shown in this figure. The closed surface consists of a hemisphere S1, a right circular cone S2, and a circular surface S3. The magnetic flux through S1 and S2 respectively. So here we have a diagram. Now this question was given as a bonus question in this particular year when this came, because they forgot to mention the unit of this. I tried to write it, but somehow it is not clear. They forgot to mention the unit of this radius. Without this unit, you will not get any one of these answers. So that's why this question was given as bonus of this year. But if similar question comes in your year, they will definitely mention the unit of the radius, okay, and you will be able to solve it. So here question looks complicated, right? We have a hemisphere, we have a cone, we have a circle, okay. How to calculate? So remember that does not matter if surface is hemisphere or cone, okay. Every field of line is passing through this. Every field of line is passing through this surface, okay. Every field line is passing through this surface, okay. So if you calculate the flux, if you calculate the flux through this, okay, this is incoming flux. Incoming fluxes are negative. Incoming fluxes are negative. Outgoing flux is always positive, so this will be positive. Outgoing flux is positive, incoming flux is negative, okay. So and both of them should be same value. Both of them should be same value. So S1 is negative, S2 will be positive, okay. Now we have to calculate that. How to calculate? Obviously we know that magnetic flux is magnetic field into area, okay. What is the area of this circle? Area of the circle is pi r square, and magnetic field here is 2 millitesla. 2 millitesla means 2 into 10 to the power of minus 3, and area is pi r square. Very simple question, very simple answer. Only without the unit, microweber will not come. That is why it was given as a bonus question. So 2 into 10 to the power, many students said, okay, I made a mistake, so maybe it was good for me, okay. Now let's solve. 3.14 into, sorry, not 3.14 is not required, because eventually pi will cancel. So pi into r square. R square means 10 by root pi. 10 by root pi whole square, that is 100 by pi, and it is centimeter. It is given in centimeter. So centimeter is 1 centimeter is 10 to the power of minus 2, and because there is a square of r, that means it will be 10 to the power of minus 4, okay. Pi cancels, and we get 2 into 100, that is 200 into 10 to the power of minus 7. Minus 3, minus 4, minus 7, that is 20 into 10 to the power of minus 6, that is 20 microweber, okay, 20 microweber. So the incoming is negative, outgoing is positive, so option A is correct. As I mentioned, because they forgot to mention the unit, you will not get 20 microweber. If you take this as, by default, if you take this as meter, it will not come to be microweber, okay. It will come out, I think, 0.2 Weber, like that, okay. So that's why this question was given as bonus. Yes, 19A is answer for this question, right? Sir, when the complete physics one shot, Kania, first of all, PU2 one shot lecture is already available. PU1 one shot lectures are coming very soon. From, I think the first lecture of PU1 will go today for physics, okay. PU2 one shot lectures are already done, okay. It is available. Check master stroke 2026. There we have discussed all the important concept of your PU2 chapters. All the PU2 chapters are done. PU1 chapters will start coming today, and we will try to close it as quickly as possible, okay. We might give two chapters in one go, so it will be over very soon, okay. In the figure, a conducting ring of certain resistance is falling towards the current carrying straight long conductor. the ring and the conductor are in the same plane. So here we have a current carrying wire, a ring is falling on this. Okay, so they ask you, this is along the same plane as the current carrying wire. Okay, so here the induced electric current is 0, induced electric current is anti-clockwise, induced electric current is clockwise, ring will come to rest. Obviously this is wrong, ring will not come to rest because of the gravity. So because of the gravity, the ring will keep on falling till this wire. And what is the direction of the induced current, that you have to figure out. Now is it 0? First of all, so let us understand, the current is being carried like this, the ring is falling like this. So obviously it will not be 0. Why it will not be 0? Because magnetic field, due to a straight current carrying wire, the magnetic field is always in circular pattern. That means it is going like this. And as you move away from the wire, okay, the field lines actually becomes weaker. So it is into the page of the paper. So it is into the page of the paper. Okay. So this is the current carrying wire. Sorry, not into the, out of the page of the paper. It is out of the page of the paper. So this is the direction of current. Magnetic field lines due to a current carrying wire can be determined using right hand rule, thumb rule. This is the direction of current, and your fingers point the direction of magnetic field. So it is out of the paper. And magnetic field here is weak, magnetic field near the wire is very, very strong. Okay, so here it is weak, here it is strong. So the loop is falling from weaker magnetic field to stronger magnetic field. The loop is moving from weaker magnetic field to stronger magnetic field, and it will try to oppose this increase in magnetic field by producing a magnetic field which is into the page of the paper. So it will try to produce a magnetic field into the page of the paper. That means the direction of magnetic field will be clockwise. This is the direction of clock. Our clock hand rotate in this direction, so it will be clockwise. Induced magnetic field, I think induced electric current is clockwise. Induced electric current will be clockwise, so that the magnetic field is into the page of the paper. Okay, so induced EMF will be into the page of the paper, so that the current is in the clockwise direction. Okay, this is the induced EMF, induced magnetic field. Okay, so this is very tricky question. If you understand what is happening over here, you will be able to answer. If you don't understand, you will just mark it as 0 and you will get 0. Okay, so it is in the clockwise direction. Now remember, clockwise means if anything rotates in the clock's direction, then it is considered clockwise, here like this. If it is rotating in the opposite direction of the clock, it is called anti-clockwise. Clockwise, anti-clockwise, also very, very confusing for many of you, I know. Okay, when I was a student, I used to be confused with clockwise and anti-clockwise. Later on I figured out. Okay, let us imagine the clock. Okay, in the exam hall there is a clock there, okay, to obviously to check the time. So I used to, if it is clockwise or anti-clockwise, I used to look for the clock. Okay, and I see, okay, this is rotating in this direction, my direction is same, so that's how I used to figure it out. Later on it came to me naturally, but initially especially during my initial years of class 10th, where we studied this clockwise, anti-clockwise for the first time, it was very confusing for me. Okay, an induced current of 2 ampere flows through a coil. The resistance of the coil is 10 ohm. What is the change in the magnetic flux associated with the coil in 1 millisecond? So here basically they have given you that induced current is given. Induced current is given and the resistance is given. Okay, and they ask you what is the change in flux in 1 millisecond. So completely different question. What is the relationship? We know that rate of change of magnetic flux is actually magnitude of EMF. That is a negative sign, but for unless and until we require, we will not use negative sign. Okay, so induced EMF, rate of change of magnetic flux, is equals to induced EMF. Now what is induced EMF? EMF is same as voltage, so we can write induced EMF as Ohm's law, V equals to IR. Okay, so induced EMF is nothing but voltage source, right? So it will be E equals to IR. So we just need to find the d phi value when dt equals to 1 millisecond. Okay, so that is what our target is. So d phi will be equals to epsilon, that is IR dt. What is I? I is given here 2 ampere, resistance is 10 ohm, time is 1 millisecond, millisecond means 10 to the power of minus 3. So that will be 2 into 10 to the power of minus 2. Okay, 2 into 10 to the power of minus 2 Weber. So correct answer option B. Ayan Pasha is saying we watch anime. Yes, you can watch, but first finish your KCET exam. Okay, once KCET exam is over, you can watch, no matter, you can finish your entire series of One Piece starting from episode 1 till whatever 1000 and some episodes are there, right? Watch them. Okay. A square loop of side length A is moving away from an infinitely long current carrying conductor at a constant speed V as shown over here. So here we have a current carrying loop which is slowly moving away from the current carrying wire. Okay, let x be the instantaneous distance between the long wire and the loop. Okay, the mutual inductance M of the square loop long conductor pair changes with time t according to which of the following. So they have said that this is x. Okay, and now the loop is basically going away from the wire slowly. Now what is the mutual inductance between this wire and this loop with time, how it is changing? Okay, so mutual inductance, now you can calculate that. Basically, as I mentioned, this is a complicated calculation, but you should remember one thing, that KCET loves a particular graph pattern, that is this. Okay, so mutual inductance, as the loop moving slowly away from it, its mutual inductance, obviously distance increases, and because distance increases, the mutual inductance decreases. So with time, okay, the mutual inductance decreases and it is inversely proportional. So the graph will be this one. So if you have to guess anything, always guess this graph pattern. Okay, if you want to guess, this is the graph pattern. If you know, there are some instances, as I mentioned, 90% cases this will be correct, 10% other options might be correct as well. Okay, some cases this option is not at all given, so then you have to figure it out. Okay, now let's move on. The current in a coil changes from 2 ampere to 5 ampere in 0.3 seconds. The magnitude of EMF induced in the coil is 1 volt. The value of self-inductance of the coil is. So they ask you self-inductance, but they, in the question they have given how the current is changes from time. Okay, magnitude of the induced EMF is also given. We know that induced EMF in a coil, coil means a loop, it can be loop, it can be a loop like this. Okay, this one we use in case of AC chapter, right? Inductor. So we know that in an inductor, induced EMF is given by L into di by dt. Induced EMF is L di by dt. So here induced EMF is given as 1 volt. We are trying to find the self-inductance, that is L, and current changes from 2 to 5, that is 5 minus 2, divided by time is given as 0.3 seconds. Okay, so it will be L into 3 by 0.3. Okay, that is L into 0.1. Okay, L into 0.1. Sorry, not L into, L divided by 0.1. Okay, 3 and 0.3 cancels. So we get on the left hand side we had 1, on the right hand side L by 0.1. So L equals to 0.1 Henry, or 1000 into 10 to the power of minus 3 Henry, or 1000 millihenry, 100 millihenry. Okay, so 100 millihenry is the answer. Okay, 0.1 millihenry, don't, you found 0.1 and you saw 0.1, don't mark it. Okay, this is a unit trick question. Okay, the only thing is the unit has to be matched. Here you found the answer in Henry. Okay, it is not in millihenry. Unless and until you have a particular problem, the units will always be in Henry, Newton, okay, watt, etc. So you have to convert kilowatt, milliwatt, microwatt, microjoule. Those you have to do it manually. Okay, unless you have a 10 to the power of conversion factor there. Okay, so here by default inductance is Henry, so the answer will be in Henry. So don't mark this as your correct answer. You have to check the unit, because the answers are given in millihenry. It will be 100 millihenry, not 0.1 millihenry. Okay, now next, a metallic rod of length 1 meter held along east-west direction is allowed to fall down freely. Given the horizontal component of Earth's magnetic field BH equals to 3 into 10 to the power of minus 5 Tesla, the EMF induced in the rod at an instant t equals to 2 seconds after it is released. Now Kanya, don't spam, you answer. Sir, answer is not 1 Henry. Prajwal, it will be 100 millihenry. Okay. Varu, use headphones, earphones. Okay, I am talking as loud as possible. Okay. Ali, Mir Zafar, don't do that. Okay, the people are trying to learn, so don't talk like this. Okay, maybe the older phones do have a problem in the speaker. Some of the phones, your speaker may be jammed. Okay, in those cases voices can be reduced. You can do one thing, you can increase the resolution from auto to at least 720p. That will give you a better audio quality. Okay, if you increase the resolution of the video to 720p, you will get a better resolution. If you have a faster internet, you should watch it in at 1080. But if you are watching from mobile internet and it is daily rechargeable like 2.5 GB or 1.5 GB, then watch it at 720p. That will give you a better audio quality than you are listening. Or generally by default it gives you a 480p resolution. That gives you a lower audio quality. Okay. What, Shesharao? What, repeat? Sir, how many questions are left? 24th question is there. After that 25, 6, 7, 8, 9, 10. Okay, 6 more questions including this 7 question. Okay, not many questions are there. I am planning to close the session by 11, so please help me. Okay. Now let's see. Here we have a magnetic field which is falling, a magnetic rod. A rod is falling in the magnetic field. Okay. So now here one problem is there. So the rod is falling in the magnetic field. It will not be horizontal component. It will be vertical component. Okay. No, horizontal component. Sorry, it will be horizontal component. Yes, perfect. So horizontal component means a component like this, and it is falling along this. So what is the particle is moving downward with the velocity say v. Then what is the induced EMF? we know that induced EMF, motional EMF is BVL, right? L is given 1 meter, B is given, okay, but if you see that velocity is not given. Okay, so even though the formula is easy, they like to make things little complicated, so that's why they have not given you the velocity V. So how to find velocity V? They have given that at an instant 2 seconds after it is released. So basically it is a concept of motion in one dimension where you have a ball, you drop it from height h or some height, okay, what will be the velocity after 2 seconds? After 2 seconds, what will be the velocity? So basically this part you have to use your first PU concept and then use that velocity to calculate the induced EMF. Okay, so initially the velocity is 0, okay, the gravitational acceleration acting on this object is g, so we can say that the final velocity is g into t, right? V is equal to at, V equals to at, V is equal to u plus at, u is 0, okay, not V is 0, u is 0, so V is equal to u plus at, u is 0 over here, so only g into t, g is 10 and time given here is 2, so 20 meter per second is the instantaneous velocity at this moment. Okay, so what will be, not very difficult formula obviously, so what will be the EMF induced? EMF induced will be B equals to 3 into 10 to the power of minus 5 Tesla, velocity is 20 and length of the wire is 1 meter, so it will be 3 to the 6 into 10 to the power of minus 4 volt. Unit of induced EMF is same as the potential difference, so correct answer is 6 into 10 to the power of minus 4. Okay, Prajwal, this year also you will take the cup, don't worry, I have no problem at all with that, but don't discuss in here. Sir, if the rod is thrown with the velocity v and at the certain point, what is the induced EMF if b is equal to 10 to the power of minus 5 Tesla? So if you throw it, then you have to calculate the velocity by equals to u plus at. Okay, now if you throw it downward, u will be positive, you have to take both of them positive. If you throw the rod upward, then it will be, the g will be negative, u will positive, g will be negative, okay, because the gravitational acceleration is acting downward but the object is moving upward. Okay, so based on that you have to calculate the final velocity. Once final velocity is calculated, the problem is same, BVL, motional EMF. Okay, motional EMF formula we have derived. In fact, this formula was asked to write in the exam also. Okay, only write the motional EMF formula, not the derivation, but they ask you write it down, right? So you have to mention BVL and mention the terms, right? So so this is how you should solve. Find the velocity using this equation of motion, and once velocity is calculated, put it in the formula. That's it, very simple. Now next is this, a square loop of side. So this is an example where the favorite pattern of KCET is not being given as an option. Okay, so how to answer such question? Let's see. A square loop of side 2 centimeter enters a magnetic field with a constant speed of 2 centimeter per second as shown. The front edge enters the field at t equals to 0. At t equals to 0, this front end enters. Okay, with which of the following graph correctly depicts the induced EMF in the loop? Okay, take clockwise direction as positive. So first of all, the only problem that is there, we have to find the direction of the induced EMF. If you can find the direction of the induced EMF, the problem is very simple. Obviously, when the loop is entering, the magnetic field starts getting into the loop, and because it's moving with a constant velocity, suppose initially after t is equal to say 1 second, only 1 is there, after t is equal to 2 seconds, 2 is there. Okay, and because the rate of change of magnetic field is constant, the induced EMF will be constant, it will not vary. It will not vary like this or this. So these two are incorrect. These two are incorrect. So either this one or this one is correct. So once the entire loop is inside the magnetic field, the magnetic field is no longer changing. That means magnetic field will be 0. And when the loop starts exiting the loop, okay, when the loop starts exiting the magnetic field, again induced EMF will be there in the opposite direction. So in that sense, these two graphs are possible candidates. Okay, this is not correct. So it is increasing, then suddenly it is going in the opposite direction, and then having this kind of graph. Okay, so this is incorrect. Here nothing is given, suddenly one line appears and then one line appears. Again this is incorrect. Okay, so these two are incorrect options. Either this is correct or this is correct. Magnitude you don't need to worry about. Okay, these magnitudes you don't need to worry about. If you find the direction of EMF, okay, whether it is clockwise or anti-clockwise, that's it. Okay, so what is the magnetic field direction? Magnetic field direction is cross. Cross means into the page of the paper. Dot means out of the paper. Dot means out of the paper. Cross means into the page of the paper. Now how to remember cross and dot? I always tell you that remember cross is like a target, okay, where you are throwing. Those who have played dart game, okay, nowadays very common. Okay, you hang a target in the wall and you throw small pins towards the dart. So this is like a target. Okay, so you have to hit the bullseye. So that means it is going into the page. And dot means opposite that of the cross. That means it is coming out of the page. Okay, so cross is your target. You have to hit the bullseye, and hitting means going into it. So it is into the page. And dot means opposite of the going into the page. It will be out of the page. Okay, now so when the loop is going inside the magnetic field, okay, magnetic field is into the page, and the induced EMF will try to oppose this into the page of magnetic field. So it will produce a magnetic field of out of the page. The induced EMF due to this loop will be out of the page. Okay, I kept everything in red color so that you can understand. This red color represents this loop's magnetic field. So this loop will induce a magnetic field which is out of the page. So out of the page means what will be the direction? This way, and this is anti-clockwise. This is anti-clockwise. So initially induced EMF when it is entering will be anti-clockwise. That means it is negative. When it is exiting the magnetic field, it will try to hold on to the magnetic field. It was there, my mentor, my teacher, I don't want to go out. So now it will produce magnetic field in the direction of the same field. So it will be positive. Okay, so initially it will be negative, and finally it will be positive. So correct answer is option D. You don't need to worry about the unit values. Values are all same values. Okay, you don't need to calculate. So mathematical calculation is not required, only analytical calculation is required. Okay, for analytical calculation you need your head. So remember that if magnetic field is increasing, induced EMF always try to oppose that increase. So that's why it will try to induce an EMF which is opposing this cause. When the magnetic field is decreasing, it tries to increase the magnetic field. That means it will produce a magnetic field in the same direction. Induced EMF is very tricky. Induced EMF is very tricky. When you are increasing it, it says stop, stop, stop. When you are decreasing it, it says no, 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 give me more, more, more. Okay. What is the doubt? Naveen has a doubt and you are asking me, sir, Comet K30 I joined, sir. Is that enough, sir, or any other I should do, sir? Naveen 760, if you can afford, along with Comet K30, you should also join Comet K test series. Okay, in Comet K30 you will get 5 tests. Comet K test series you will get 12 tests. Okay, test series is unique, and test series has very specific tests in it. So if you should also join Comet K test series. Okay, that's sufficient. Classes will start from 6th of April. few more days, 5 more days, the classes will start. So don't worry if you are thinking the classes have not started. Okay, classes will start from 6th of April, and it will be very intense classes. All the lectures will be there. We will be coming live. We will discuss all the doubts that you have. Okay, so you will clear your doubts as well, and all the lectures will be delivered on time. You will get the DPPs. You will practice a lot of questions also along with us. Okay, so that is sufficient. But if you can afford, you can buy the test series. Okay, that's it. Then you should be fine. Okay, now next, a long solenoid has 500 turns. When a current of 2 ampere passed through it, the resulting magnetic flux linked with each turn of the solenoid is 4 into 10 to the power of minus 3 Weber. Then the self-induction of the solenoid is. So you have a long solenoid. You have how many turns? You have 500 turns. Okay, where a current of 2 ampere is passed. The current is 2 ampere. Okay, resulting a magnetic flux linked with each turn of the solenoid is 4 into 10 to the power of minus 3 Weber. Then the self-induction of the solenoid. So here, what is the magnetic field linked with the coil? Okay, so just a second. The flux is given. Flux with each coil is given 4, right? 4 into 10 to the power of minus 3. Now they ask what is the induced, what is the self-induction? Now we know that induced EMF is given by d phi by dt, n d phi by dt. Okay, induced EMF in a coil is given by n d phi by dt. Okay, n is the number of turns, d phi is the flux linked with each coil, and again for self-induction the same thing is given as L di by dt. Both are same formulas. Okay, d phi by dt and L di by dt are same. Only in case of more number of turns we also have to consider the number of turns. Generally we use d phi by dt, but for number of turns you have to use n d phi by dt. So obviously dt cancels. Okay, so if you integrate both sides you get n phi equals to L into I. Okay, n into phi equals to L into I. So phi is given, I is given. You have to find self-inductance. So self-inductance is n phi by I. Okay, phi is given, I is given as 2 ampere, and number of turns is given as 500. Okay, so just put the values. So L equals to 500 into 4 into 10 to the power of minus 3 divided by 2. So 2 cancels and you get 2 into 500 is 1000 and to the power of minus 3, so that is 1 Henry. Unit is 1 Henry. In this case this is 1 Henry. So Prajwal was saying 1 Henry in another question, that is wrong. Okay, so option C is correct. Guys, please stop for a while. Please stop your discussion for a while. Let me conclude the lecture, then you can continue discussing. Match the following types of waves with their wavelength ranges. Okay, we all have exams, right? We all have exams, so don't waste time. Just focus this on this lecture first, then you go and discuss whatever your free fire programming. So microwave, visible light, ultraviolet light, X-rays. Okay, wavelength ranges are given here. So first of all you have to understand which one have the highest wavelength out of the given rays. Okay, microwave have highest wavelength. Okay, and no extra options are given, so we are lucky. So if you see that which one is the highest wavelength in this given range, okay, highest wavelength is 0.1 meter to 1 millimeter, that is the highest wavelength. So that must be matching with microwave. Okay, if you remember that the highest in terms of wavelength, okay, radio is number 1, then micro, okay, then we have infrared, then we have visible, then we have ultraviolet, then we have X-ray, and finally we have gamma ray in terms of wavelength. As you go down, wavelength decreases, and for frequency as you go up, frequency decreases. Highest frequency for gamma ray and lowest for radio. Okay, this table, if you remember that when you start here to here, wavelength decreases, and if you go from here to here, frequency decreases. Okay, that will be very, very helpful. So microwave matches with this one, must be, obviously it has to be. Next in the line is visible. Okay, visible ray, we know it is between 700 nanometer to 400, so this one is no trouble, so this must be option 2. Ultraviolet is between visible and X-ray. Now let's figure out X-ray. X-ray will have the smallest wavelength. X-ray will have the smallest wavelength. Now for smallest wavelength here is nanometer to 10 to the power of minus 3 nanometer. Obviously smaller the number, smaller the wavelength. So this must be the X-ray. So this must be the 4, and whatever is left, that should go with ultraviolet. Ultraviolet starts exactly after violet. Violet is 400, so that's why it is starting from 400. So this is ultraviolet, that is 3. So correct match is 2413. 2413. Okay, I think they have okay. One with sorry, not 2413, it will be CADB. Okay, CADB. So correct match is this one. If you match at least one of them, no, you should get the correct answer. So microwave matching with this, if you find this out, you will see that that is unique. One matching with C is not even given in any other options. So if you only know one of the correct match, probably you will get the correct answer for your question. Okay, all the matches are random, so if you even get one of them correct, you will get the correct answer. So try to at least get 2 of them correct. The ratio of magnitudes of electric field to magnetic field of an electromagnetic wave is in the order of. So electric field to magnetic field actually gives you the speed of light or speed of the electromagnetic wave, which is 3 into 10 to the power of 8. Now this is in vacuum. If this is in any other medium, the value will be slightly less than 3, but the order should still be 10 to the power of 8. So electric field to magnetic field is 10 to the power of 8. Magnetic field to electric field will be 10 to the power of minus 8. Remember this also. Sometimes they might say magnetic field to electric field. What is the order? Then you have to remember electric field is always stronger than magnetic field. Electric field is always stronger than magnetic field. If you divide electric field by magnetic field, then only you get 10 to the power of 8. If you divide magnetic field by electric field, you should get 10 to the power of minus 8. Who is lavender? Ayan Pasha, you don't want to pass? Which of the following, you don't want to top, right? Ayan Pasha, you just want someone else to be topper. Which of the following radiations deflected by electric field? Okay, X-ray, gamma ray, alpha particles, neutrons. which of the following radiations deflected by electric field? Electric field can deflect another charged particle. Okay, it cannot deflect any electromagnetic radiation. Gamma ray is a electromagnetic radiation. X-ray is another electromagnetic radiation. Okay, neutron charge is 0. Okay, but alpha particle, they have a charge of +2 electron. Okay, alpha particle is doubly charged helium nucleus. Okay, alpha particles are doubly charged helium, which is basically helium nucleus. So that means they will be they can be deflected by electric field. Similarly, if they give you an option called beta particle, okay, beta particle, remember that beta particles are also charged particle which are electrons. Okay, they are negative electrons. So basically beta particles can also be deflected by electric field. Okay, but X-ray, gamma ray, they cannot be deflected by electric or magnetic field. Last question, last but not the least. Suppose that the electric field amplitude of electromagnetic wave is E0 equals to 120 Newton per Coulomb and its frequency is 50 megahertz. Then which of the following value is incorrectly computed? This is one of the difficult question from this chapter. Okay, magnetic field is given. So electric field is known. Electric field is known. So if you divide by magnetic field, you should get 3 into 10 to the power of 8. Okay, speed of light. So from here you can say that B0 equals to E0 by 3 into 10 to the power of 8, or 120 divided by 3 into 10 to the power of minus 8. So it will be 40, and it will be 400 into 10 to the power of minus 9. So we have increased 1 0 and decreased 10 to the power by 1. So this is 400 nano Tesla. So 400 nano Tesla is correct. Angular frequency of electromagnetic wave. Angular frequency of electromagnetic wave is pi into 10 to the power of 8 radian per second. So what is angular frequency? Angular frequency omega is equal to 2 pi f. Angular frequency omega is 2 pi f. Frequency here is given 50 megahertz. So 2 into pi into 50 megahertz means 10 to the power of 6. Megahertz means 10 to the power of 6. So it will be 100 pi 10 to the power of 8. 10 to the power of 6, or pi into 10 to the power of 8. So these two zeros included here. So pi into 10 to the power of 8 is also a correct option. Propagation constant angular wave number is 2.1 radian per meter. So angular wave number is 2 pi by lambda. Okay, angular wave number is 2 pi by lambda. Now how to calculate that? It can also be calculated as omega by 2 pi. Okay, angular wavelength, angular wave number or propagation constant is given by omega by 2 pi, right? I think this is not correct. Okay, let's come back to this little bit later. First say that wavelength of electromagnetic wave is 6 meter. So what is wavelength? Wavelength is the distance traveled by the light in one oscillation. That is, we know that relationship between speed of light and wavelength. Speed is equal to frequency into lambda. right? Speed equals to frequency into lambda. V is equal to nu lambda. In wave motion we have studied it. So C is equal to F lambda. C is known over here. C is 3 into 10 to the power of 8, and frequency is 50 megahertz. Megahertz means 10 to the power of 6 into lambda. So lambda equals to 3 into 10 to the power of 8 divided by 50 into 10 to the power of 6. Okay, so 10 to the power of 6 cancels, we get 100, 100, and we get cancelled by 2, so 6 meter. So this one is also correct statement. So obviously this one is wrong. You can even calculate that K is 2 pi divided by 6. Wavelength is calculated now. So it will be pi by 6, that is 3.14 by 6, approximately 0.5 radian per meter. So obviously 2.1 radian per meter is not correct. So this is correct, this is incorrect. Okay, again as I mentioned, this is one of the difficult question. You have to verify each and every options to eliminate the incorrect option. Okay, this is not easy question. Here you cannot even guess the answer. Okay, if the guess that you do will be wild guess. Okay, because obviously all the values, if you see that all the values are looking random, but all the values are actually coming out to be correct, right? So E naught by B naught you calculate B naught. Okay, C is equal to F lambda, you calculate lambda, and omega is equal to 2 pi F, you calculate omega. In case you forget K, leave it. Okay, later on you will realize whether it is correct or wrong. If any one of the first few things that you calculate turns out to be wrong, you saved a lot of time. But if you don't do that, then you have to use a lot of effort to solve it. See, your exams are there. Okay, you are discussing some random things. So if you want to download the PDF at least after the lecture is over, then what you have to do, join the WhatsApp channel, and whenever there is a live coming up for physics or chemistry or biology or mathematics, you will be notified through the WhatsApp channel. So if you have not joined the WhatsApp channel, don't forget to join it, and please like this session. Stop chatting, close the live chat, like the session. Okay, like the session now, like the session, so that otherwise I will not be doing questions in future. Okay, everyone, Jayashree, Sanjana, Ayan Pasha, Mirza Zafar. Okay, 25 I can't understand. 25, let's go back to question 25. Okay, so 25, let us understand this. What is happening here? We have a loop. Okay, this is going into a magnetic field. So if we have a loop, any loop, shape does not matter, any loop, okay, when you change the magnetic field lines passing through this loop, okay, by moving the loop into a magnetic field zone, okay, what will happen to the loop? The loop will induce magnetic field. Okay, so if magnetic field linked with the loop, actual term is magnetic flux. Okay, field lines, now field lines per into area is called magnetic flux. So magnetic flux actually gives rise to induced EMF. More field lines are passing, and now if the field line is constant, suppose it has a very high magnetic field but they are not changing, then induced EMF will be 0. So you have to change the magnetic field so that it can induce EMF. So here what we are doing, we are dragging this loop into the magnetic field. As you are dragging the loop into the magnetic field, okay, by a constant velocity, velocity is constant, that means the induced EMF, the magnetic field linked with the loop will change uniformly. Magnetic field linked with the loop will change uniformly. Okay, so suppose first 1 second 10 lines crossing the loop. Okay, next 1 second 20 line will cross the loop, but change will be 20 minus 10, that is 10. Okay, so the change of the line that is passing through the loop will be constant because of the constant velocity. Okay, in fact we know that induced EMF is given by B V L, right? Now L is constant, L is the length of this wire. Okay, L is constant, V is constant, B is constant. So induced EMF will also be constant. It will not change with time. And because it is not changing with time, we can eliminate this one and this one. This one is changing with time in a straight line pattern. It is decreasing here, it is increasing here. This one is a random graph is shown. So this has no meaning, so you can ignore these two graphs. Now what? Now why there is a complete flat line over here? The complete flat line represents when the entire loop comes inside the magnetic field. When the entire loop comes inside the magnetic field, the field line is no longer changing. So the magnetic flux will be constant. So induced EMF will be 0. So that means in between, when the entire loop is inside the field, no change happens, so induced EMF is 0. When the loop goes out of the magnetic field again, there will be an induced EMF. Okay, now induced EMF always opposes the cause. Induced EMF always opposes the cause. Okay, so if the original field is inside, the induced EMF will be outside. Okay, when you are increasing, if you think about one position, the other position will be just opposite of it. Don't think too much. Okay, if you think that, okay, when the loop is going into the magnetic field, field lines are increasing, that means flux is increasing, so it will oppose that increase, so it will produce an magnetic field of its own. It will produce a magnetic field of its own. This loop will produce a magnetic field of its own which opposes the original magnetic field. So when you are entering the class, the teacher is trying to teach you, you are talking too much, okay, because you are not concentrating on the class. You are trying to create your own teaching or you are trying to teach your own philosophies to your friends. Okay, hey, come to play Free Fire today. Okay, sir is teaching something very important, but you are discussing what we will do. Okay, sharing your ideas, playing games. So basically this loop is like that. So this loop is opposing. I don't want to study, I will keep as it is. So basically what happens, when the loop goes into the magnetic field, it opposes this motion and it produces its own magnetic field. That magnetic field opposing the original magnetic field. So original magnetic field is into the paper. So what will be the opposing magnetic field? Opposing magnetic field will be out of the paper. And who will produce that? That will be produced by this loop. So this loop is producing a magnetic field out of the paper. Now how to find direction of current? Direction of current is you point your finger in the direction of induced field, okay, and then you open your fingers, and if you curl it, this points in the direction of current. Okay, so that means the current is in this direction. For here it is in this, for here it will be here, for down it will be like this, and it will be like this. Okay, for all case it will be like this. So induced EMF is out of the paper, induced magnetic field is out of the paper, so induced current will be in this direction, that is anti-clockwise. Now in the question it is mentioned, take clockwise direction as positive. So clockwise direction is positive, means this axis is positive, this is the positive axis, this is the negative axis, right? X axis, Y axis, X is always positive because we are talking time. Y axis, this is positive, this is negative. So induced EMF at the starting point, what it is negative. So induced EMF here is negative. Negative means what? The induced EMF will be the below part. So you have already eliminated these two graphs. So either this or this. This one is giving me induced EMF positive. That is not possible. So induced EMF will be negative initially, and later on it will be reversed. It will be positive. So obviously if you find out one, you will be able to answer the question. Rohan is saying KCET exam dates changed, check official website suddenly. Okay, Rohan, I will check. I also do not have this information. Thank you for informing me. Okay, I will check it, and if any urgent updates is there, we will definitely inform you. Just wait for few hours. Jasmine ma'am or myself, we will update you very soon. Please don't worry about it. Sir, want to score 45 plus. So if you want to score 45 plus, solve all the PYQs as much as possible, okay, and make a formula sheet. I have shared one PU2 formula sheet. PU1 formula sheet is on the way, okay. We will give you very soon. Make a formula sheet, try to solve PYQs as well as few new questions. For new questions, obviously you can use any textbook. If you do not have textbook, you can use our ABHYAS test series, where you are going to get unique KCET level questions. No bullshit, all the questions are very KCET level, and we are not going to give you any out of syllabus questions as well. So do check ABHYAS, or if you have book, I am not forcing you to purchase ABHYAS. If you don't have, ABHYAS price is one of the lowest, 999 for all subjects included. So that is one thing. If you want to purchase one book of the publisher, that costs about 700-800 for subject. So 3 subjects 2100. Okay, so you can if you want to purchase PYQ book, Vedantu 20 years PYQ book available at 3,999 for all 3 subjects again including. So that is also one of the cheapest available PYQ books. Okay, so PYQs and questions practice should not stop. Okay, practice more and more questions at this stage, and if you are weak at some of the chapters, you can come back and check our master stroke. In that, for that particular chapter, if you think, okay, this chapter I have prepared enough, I will be able to answer all the questions, then it's fine. If you are not able to understand few of the concept, come back and check master stroke of that chapter. That will help you, give you clarity. Okay, Rohan, you are making fool of me. Very good. Ayan Pasha, you earn money. How can he earn money? Once he becomes an AI engineer, he will earning a lot of in CRs. Okay, lot of CRs, and you will still chat in the Free Fire chat box or in the YouTube chat box, right? No problem, Tashmia. As this is my duty, I am a teacher. I will explain as much as long as my students don't understand, I will try to make the concept as clear as possible. Okay, sometimes it's difficult because obviously there are multiple students are here, and these people are discussing garbage over here. I am not getting, even if you are commenting something important, I am missing it because these students are discussing garbage. Okay, I am checking the chat and I am seeing, sir, what is this? Okay, anyway, thank you everyone. I will see you in the next lecture, maybe tomorrow afternoon, evening. Okay, and that will be clarified through WhatsApp channel. If you have not joined WhatsApp channel, join it, and definitely like this lecture. I did not see any one of you are discussing garbage in my live chat. Okay, and you are not liking my session. Next time if I see you discussing garbage in my session, I will block you. Okay, I will block you seriously. I don't care about anything else. If you discuss garbage without liking my video, I will not allow this conversation. Okay, see you in the next class. Till then, bye.